Hello, hackers. How are you doing? My name is Taggart. Welcome to Saturday Hacker Day. And as always, we begin on Saturdays with a review of the week's cyber news. Some really interesting stories this week that I'm excited to talk about. First up, we have the White House Cyber Summit. I don't actually know if that's the official term, but it's explanatory. We had this week a massive congregation of corporations and other cyber luminaries at the White House to talk about the future of cybersecurity, including companies like ADP, Amazon, Apple, Bank of America, Code.org, which actually is a nonprofit, not a company, Girls Who Code, Google, of course, IBM, JP Morgan Chase, Microsoft, Vantage Group. There are a bunch of others. A number of commitments and kind of decisions have come out from this meeting. Hey, Angel, good to see you. Welcome aboard. And I think a couple of the top line ones that are worth talking about. The first is from the big players. So Microsoft has committed to investing $20 billion over the next 5 years to, quote, deliver advanced security solutions, in addition to making available 150 million in technical services specifically for U.S. federal, state, local, and federal, state, and local governments to upgrade their security situation. I have also seen rumors or actually not rumors, but kind of unconfirmed reporting that they are also planning to make many of their enterprise security solutions that are kind of at their top level license, the E5 license, free to all of their customers, so that if you have an Azure account with them, if you're using Azure Active Directory, anything else like that, you're going to be able to get some of that advanced logging that otherwise would cost a lot of money for free, because organizations just need to have that kind of visibility. And even if you can't afford it, right, the decision may be made that it's better to give away this logging because it's necessary, right? And you don't want to have the reputation of enabling cyber attacks. Google is planning on investing over $10 billion to bolster cybersecurity, whatever that means, including expanding zero trust programs. It's all very vague at this moment, but Google has put out a blog post. I'll put that in the chat for anyone who's interested in following that further. And they're also spending some time enforcing standards or creating standards called the supply chain levels for software artifacts, so that supply chain attacks will have a little bit more of a protective layer. Apple is planning on working with more than 9,000 of its suppliers to push for multi-factor authentication, to do better vulnerability management, and of course, better logging, security baselines. So Apple's taking that on. IBM plans to train 150,000 people in cybersecurity skills. And in particular, they're going to be partnering, this is really exciting, with 20 HBCUs, or historically black colleges and universities in the United States, to improve their cybersecurity education programs. And then lastly, amongst the heavy hitters, we have a commitment from Amazon to make available to every AWS account holder, even if you're on the free tier, a multi-factor authentication device to protect against phishing and password theft. So that'll just be available to everybody at no cost. I'm really hoping that Google does sort of the same thing with their Titan key that was so effective at limiting the attacks against their own environment. And I'm a big believer in physical two-factor authentication, not necessarily, with a phone, but with actually a physical key. I think it's really effective. So hopefully we'll see more of that. There's a lot to do, of course, in actually having these organizations not just make promises, but deliver on what is going to improve the national and international cybersecurity posture. And I would also add that there's a flip side to this too that isn't getting talked about here. Of course, these one of the reasons these companies wanted to get to the White House and have this conversation first is because they want to lead in the proactive steps taken. They don't want legislative proactive steps taken. And what they are likely trying to get out in front of is something like actual liability when something goes wrong. Because so for example, when Boeing had to ground the 737 MAX because the avionics in it led to actual crashes, right? There was a financial and also regulatory penalty that they had to pay because their airplanes weren't functioning the way that they were supposed to. But that never happens in the cyber realm, right? There is no such thing as regulatory liability when Microsoft has a 0 day that gets exploited by attackers. It doesn't really happen. And of course, you can't really the criminals are the ones doing the attacking, but nevertheless, if a vulnerability has been introduced and there was some sort of process issue, there was some sort of negligence after an investigation, right? There is potentially a liability issue, and so far that hasn't been the case for these companies, and you can imagine that they don't want to have to deal with that. And so getting out in front of this growing concern, right, outside of just the infosec world about these ransomware attacks, these companies definitely want to be at the forefront of that rather than lagging and waiting for regulation to come with them. Just like Facebook is trying to get out in front of social media regulation, or trying to figure out how they can restructure what they're doing so that they aren't the subject of legislation that they didn't have a hand in shaping. Okay, moving right along, staying with Microsoft for a second, there was a really interesting finding this week about an offering in Microsoft's Azure suite called Cosmos DB. Now, I haven't personally used Cosmos, but this is a really interesting misconfiguration that allowed attackers to exploit one of the features of Cosmos, which is the ability to create Jupyter notebooks. Now, if you're not familiar with Jupyter notebooks, basically it's a way of executing arbitrary code in the cloud. I love Jupyter. I use it all the time. I use it primarily with Python, and it's very, very popular as a platform for things like machine learning and artificial intelligence and all sorts of data science research kinds of occupations. And that's part of what the Cosmos DB is offering, right? You have managed storage and you have also code that you can store in these notebooks, all kind of wrapped up into one cloud solution. Problem is that code has to execute somewhere, and when code executes somewhere and you don't control it, you're relying on the configurations that someone else has decided on for you. And in this case, that bit users of Cosmos DB a little bit because a misconfiguration allowed attackers to use the Jupyter notebooks that you can set up to essentially disclose storage account keys that allowed any Cosmos DB user to get data of Cosmos databases of any other user. Now, this has been addressed since the disclosure of the vulnerability, but nevertheless, I think there have been enough things going on with Azure recently that I want to call out that when you are dealing with a cloud solution, and in particular a low code or low management solution, you are again relying on the configurations that someone else has made and that you can't review. The trade-off is always supposed to be time, right? That it's more convenient for you to use these things and you don't have to maintain them because someone else is. And when it works well, that is true. But you have to trust that those configurations are accurate. And the more exposed to the internet a service is, the higher the probability that a misconfiguration is going to be exploited, right? So you have to weigh the probability that a configuration can be present, depending on what the nature of the technology is, and how exposed it is to the rest of the world for attackers to gain access to. And Azure assets in particular are really scary in this way because unless you are careful with conditional access and things like that, they can be accessed from anywhere on the internet. Yes, you have to authenticate things like that, but even beginning to access them is part of an attack surface area. So just something to keep in mind, especially as not everyone has migrated to the cloud yet. So as you make this migration to the cloud, definitely do not trust everything blindly and make sure that you are a little bit paranoid. Like, what defenses do we have in place if what the cloud provider has put in place goes wrong? How else can we protect our sensitive information? And lastly, just because I can't believe I'm talking about this story again, but I felt like it was worth mentioning. F5 has released yet another critical security patch for their Big IP and Big IQ network devices that allows remote code execution through their administrative dashboard. Not much to say about that. If you're running the Big IP appliances, fix them, patch them, but not a great time to be working at F5, I have to imagine, just because there's just been a slew of these things. And you got to ask yourself, what kind of code review is taking place at F5 when these continue to occur? Is the answer to just take the entire code base down to its foundation and rebuild it? Is it fundamentally broken the way that it's been designed? Or is there just a problem somewhere in the software development lifecycle that is leading to these constant vulnerabilities getting into production code? I really don't know. I don't have enough experience with the F5 devices to say one way or another, and I certainly don't work at, or know anybody who works at F5. But I do think that this pattern that we're seeing of constant, very severe vulnerabilities is cause for alarm. All right, that's about it for the cyber news this week. So we're going to move on to our main material. And today we are getting started with what will be a series of Saturdays doing this. We're going to be going through from the beginning the TryHackMe security operations and monitoring path, or modules, I guess. They have a number of rooms that are specifically designed to prepare you for a SOC analyst role. And as a security analyst myself, I'm really excited to see what they have to offer. And my intent is we're going to go through these rooms. A lot of them do have some reading material, but we're going to enrich that with my own experience and hopefully yours as well. Put in your own input in the chat. And I'm also going to bring in some other materials for enrichment. So for example, we're going to start today on basic Windows processes so that we know what a normal Windows system is supposed to look like. To enrich that material, I have the Windows internals textbook as well. And when appropriate, we're going to be looking at some of what the Windows internals textbook has to say about these processes, what they do, and how they do it. So without any further ado, let's get started. All right. Get some music back. Very good. All right, so I'm here in the core Windows process, and the core Windows processes room. And if you want to follow along, let me show you how to get to this room. So if you start at Learn, and you go down to the modules section, you'll see there's a security operations and monitoring module. And so right at the top, this is where we are here, core Windows processes. And it's funny, I haven't done really any of these rooms. I've tapped at some of these. I've done OS Query and the Splunk stuff, but my intent is to go through these and actually finish every single one of these rooms, so we all have that experience together. All right, so we're here at the core Windows processes. I have the IP address. I have the machine spun up, and I'm remote desktoped into it. So from my Kali machine into the Windows machine here, and I'm using the Ramina remote desktop client. If you want to use our desktop or free X-Free RDP, whatever you want to use, but Ramina works very, very well for me, especially with the resolution updating. And the beginning of this is just to talk about the task manager, which isn't really even a security tool, but it's something that when you're doing incident response in particular, something you do want to take a look at. We want to look at what the processes are running on the machine. So let's take a look at that. Lots of ways to get there. I like right-clicking and doing task manager on the start menu. There are no running apps, okay. But if we click on more details, of course, we'll start seeing the processes broken down. Now, Task Manager is something that everyone sees at one point or another, even if you're a general computer user. But there's a lot of power in here that folks don't necessarily take advantage of. These processes are, of course, parent-child, so we can see some of the relationships between parent processes and child processes. And if we go through services, we can also see any running services. That's really handy. Users logged into the system. And details is, I think, probably the most useful for our purposes. In particular, we can see the process ID of the process that's running. Kanji Pal, thank you so much for the follow. Welcome to the stream. And when you first begin investigating Windows endpoints, a lot of these small executables like csrss.exe or compattel runner or conhost.exe, you don't yet know what is normal, what's suspicious. And that's really what this room is all about, is trying to teach what you should expect to see on a normal, healthy Windows system. What's the stuff that's going to be running by default? What's the stuff you don't need to worry about when you see it happening? Okay, so by the way, the other thing that I want to call out, I'm going to fire up a PowerShell window here as well as an administrator, because there's a lot that you can do in the PowerShell window rather than a GUI, and depending on how you like to work, that might be a little bit more effective or more efficient for you. So let me kick up the font size on this so that we can see it a little bit better. So if I wanted to get all the processes on a Windows machine with PowerShell, the easiest way to do that would just be get process. Now, of course, each one of these is going to have a lot of information, right? The handles and all the CPU data, and all of this is stored. If we wanted to store it, we could create a variable like processes equals get process, and then I could ask for processes 0 if I wanted to see the first one. Gotcha, Bell, go ahead and ask your question. We're here to learn, and I'm happy to answer any questions. It's okay if it's off topic. If it veers off super far, I'll try to provide some resources if I can. But yeah, so I like getting processes this way because then it allows me to like filter through and search and do fun stuff like that. But that's just because I'm a command line interface dork. But the task manager also works just fine for a lot of what we might want to do. All right. And yeah, the other thing is there are other columns available to us that aren't there necessarily by default. So for example, if I go to select columns, right, I can check what columns I want. Session ID might be helpful. There's a lot here in the details that I can add, but even in processes, yeah, I can add PID, which I really like doing, so it's easy to see. And the command line is cool too, because I might want to see what command line parameters it was run with, because this can be an indicator of something weird. Okay. Talk about the details tab. Right. So these are obviously pretty basic tools. These are the things that are installed by default. Okay, so Kanji Pal, looks like you've got an issue with a GPU driver crash. You're playing games. So what I'm gonna recommend you do, friend, is join our Discord. Probably not going to be super helpful to like try to do troubleshooting over stream. That's going to be a little bit funky. But if you join our Discord and ask, I bet there's going to be a lot of folks there who are going to be able to help you out. All right, so feel free to join us there, and hopefully they'll be able to sort you out. Okay. So in addition to the basic tools, Microsoft makes available a suite of tools that are absolutely indispensable, called sysinternals. And thank you, Angel. Thanks for helping him out. Really appreciate that. So sysinternals, right, is a suite of tools most of them, created by Mark Russinovich, that improve the ability for you to understand what's going on in the Windows system. And some of the tools also have offensive capabilities, it turns out, like psexec, and procmon, things like that. But we're going to take a look at, if you want to download all of the sysinternals, you can take a look at them here, or there should be a link on this page to download all of them. I don't know why. Downloads. Yeah, sysinternal suite. So if you want to download all of the sysinternals, you can just go ahead and grab it here. Really, really handy, and it kind of gives you a breakdown of what each one does. And I believe that they have given us the sysinternal suite here, or if not, at least a couple of them, like Process Explorer. Yeah. And we'll run Process Explorer. And you can see that we're going to be able to see processes in a lot more detail. This is a very, very, very powerful tool. To understand exactly what a process is doing, how it looks. And notice also that we have a full process tree here, right? And you can see that there's a lot going on under this right here, which is win-init.exe. Definitely something that we want to learn what it means, and then you'll see some other, we'll learn about these as we go forward. So let's jump back in here. So let's also talk about Process Hacker. I don't believe Process Hacker is part of sysinternals, but it is a killer application. Let's fire up Process Hacker so you can see the difference between it and Process Explorer. So similar color schemes, but we have a lot more kind of tools here in terms of, we can look for, we have a username, we can find handles or DLLs. That's kind of a cool thing to try to do. Let's click this Amazon agent and see if we can click find handles or DLLs, right? Or LSAS, that'd be fun. All right, looking at properties, we have a lot of information about how this works. Handles is really, really cool. Handles associated with this particular process, including tokens. Yeah, Process Explorer is a great place to get started. And then, Process Hacker will really let you dive deep and even, so for example, with Process Hacker, if I create a dump file of LSAS, this is essentially the same thing that Mimikatz would be doing to try to get the memory of LSAS to get credentials. So that would be an offensive usage of Process Hacker. Where's LSAS in here? Why am I not seeing LSAS? Yeah, I was about to say, Angela, you should be able to do that in Process Explorer as well. I don't know if I can find it. Oh, there it is. Yeah, you can create a dump in Process Explorer as well. So either one of these can have that. that kind of functionality. It really just depends on, you know, they have a lot of overlaps in features depending on what you want to do and what one you get comfortable with. You know, I tend to use Process Explorer more just because sysinternals I have on like a USB flash drive. If I ever need to do an incident response or a digital forensics response or something like that, and I can just fire it up wherever I need it, right? It's easy to get at. But of course, if I do need Process Hacker, I have it on my, you know, malware analysis machine, things like that. So it depends on what you want to do. All right. And then at the last part here, they do mention get process and WMI, which we haven't used yet. All right. And as it says, the first Windows process on the list is system. The official definition from Windows internals, which, by the way, is the book that I have open, ready to, you know, cite from if need be. And let's actually talk about that book. Yeah, this is the... Oh, now we're on the 7th edition. Is that the... I think that's the edition that I have. Yeah. So this book is not cheap, right? It's a textbook, so it's like $43. And this is only part 1 of 2. It is so much information. It is so much information. But if you take the time to go through it, even piece by piece as you're trying to learn something specific, you will be in such a powerful position when it comes to understanding what's going on in the Windows operating system. I really, really recommend it. I've read through this. I've gone through different chapters a few times to try to cram it into my head. It is absolutely an invaluable resource for just understanding what makes sense and how things work in Windows. So this system process that we're looking at here, all the way up here, is the home for a special kind of thread that runs only in kernel mode. A kernel mode system thread. System threads have all the attributes and concepts of regular user mode threads. Hey Orbital, good to see you. The difference between those, you know, user mode and kernel mode is essentially what you can do with the machine and with the operating system, and you know where in memory you can access things like that. So, you know, you want to think about kernel mode as hyper privileged, and user mode as you sort of lower down the totem pole, as it were. System threads don't have a user process address space and must allocate any dynamic storage from operating system memory heaps. Okay. That's kind of a lot for getting started. But I think the big takeaway here is that there are, broadly speaking, kernel mode threads, or kernel mode processes, and user mode processes. And system is kernel mode. So what that looks like when we're reviewing it, let's pop open the properties window here. So it has no parent process, right? This was like as early as it gets. And the NT authority system user, right? This is the root user on a Windows machine. And you'll notice that, yeah, there's no path, there's no command line, right? This is kind of the granddaddy process. But if we look at it in Process Hacker, apparently, it looks a little bit different, but essentially similar. Although Process Hacker gives you the, excuse me, the image file name, ntoskernel.exe. Let me fire Process Hacker back up. So if we look at system in Process Hacker, right, you can see there's the NTOS kernel, there's our uptime. Will they be going through configure symbols in this room to get the function names instead of the weirdness? Angel, can you say a little bit more about what that means? I don't know, because I'm going through this room with you. Process hacker confirms this is legit Microsoft Windows. So, and anything unusual for this would be a parent process other than the system idle process, right? Multiple instances of system and a different PID. So remember, this system process should always be number 4. So if it isn't, that's odd. My guess, Angel, is that this is probably what you're talking about is a little bit more advanced than what this room in particular is about. I think later in this path, we'll get to that kind of thing, looking at API calls, things like that. But I probably, for this intro room, that's not really where they're at. So, what PID should the system always be? 4. Alrighty. Now we finally get to talk about a fun subsystem, smss.exe, or the Windows Session Manager. So from here, I am actually going to look that up in the Windows internals book because I want to demonstrate the level of detail that we have access to with this thing. Awesome. And I'll just show you a little bit of this. Try to keep this under fair use here. Let's search for smss.exe. There we go. Hey, Lasso, good to see you. Subsystems are started by the session manager. The subsystem startup information is stored under the registry key, which we haven't talked about registries, but that's a whole thing. In current control set, control session manager subsystems. So subsystems are essentially, think of them as environments for things to run, right? That's how, like, for example, the Windows subsystem for Linux works. And when I first heard about Windows subsystem for Linux, as a Linux guy, I was like, why is it the Windows subsystem for Linux? Why isn't it the Linux subsystem for Windows? Because it's Linux underneath of Windows. The answer is because subsystems are how Windows organizes its environment. And so there is a Windows subsystem, right? And that's for, you know, actual Windows and I/O, right? All of these different things. Because Windows was the primary subsystem, Windows decided to locate these basic functions there and have the other subsystems call on the Windows subsystem perform display I/O. So it's kind of how subsystems are how the Windows operating system modularizes its functionality. And here it says the Windows subsystem consists of the following major components. Where we're starting, which is CSRSS. We'll talk more about that in a minute. And then kernel mode drivers. There's quite a lot here to go through. The console host, but you can see all this detail that's available for us. Alrighty. Let's get back into the room then. Right, so the session manager is what starts first. Think of it as kind of, it's not the init system, but it's similar to, it's, as you can see, session 0 involves the win init, which is the init system, but it's what everything kicks off, or what everything kicks off from. The first child instance creates child instances in new sessions. So smss.exe will have more than one copy depending on how many sessions there are. and self-terminating. So what are we looking for here? Things that make sense. We would be looking for CSRSS. Oh, thank you for the resub, Lasso. Really appreciate that. Any other subsystem listed in the required value, as we just saw in the textbook, HKLM system, current control set, control sessions. Control session manager subsystems is also launched. And we can look at that registry key to see what is required. So what's normal here? Let's take a look at smss.exe and let's use Process Hacker. I'm interested in getting a little bit more familiar with Process Hacker, so let's use that. Should be up here. Or should I be looking at CSRSS? No, I should be looking at SMSS. Where are you at? And my understanding is that it's oh no, there it is. Okay, there it is, running right under system. So, normal stuff. Environments. That's so interesting that it doesn't tell me the user right up at the front here. But it does in the token section. And you want to get familiar with some of the basic user ID, the SIDs. And S1518 is going to be the NT Authority System SID. So whenever you see that, you know something's running a system. Hey, Richie. Happy Saturday to you. All right, so this is normal. We want to see smss.exe running exactly this way, right? As system from here. All this makes sense. And yeah, it's important to note that there should only be one of these at any point. Children self-terminate and exit after each new session. Richie, thank you so much for saying that. So I don't work as a teacher technically. My day job title is Senior Cybersecurity Analyst, but before that, yes, I was a teacher for 10 years. I was an educator. I was a director of technology for K-12 schools. So yeah, and my master's is in education. So yes, I do have a pedagogical background. So I'm glad you're enjoying it. Thank you, sir. So what other two processes does SMSS start? So we saw one already, and it's up here. So CSRSS, which they don't explain super well here. So I'm going to, again, go back to our textbook. So CSRSS.exe. Oh, Fluxus, thank you so much. So CSRSS.exe stands for Client Server Runtime Subsystem. So one way to think about CSRSS.exe is the intermediary between the Windows subsystem and everything else going on, right? If we think about, and in Linux, this is very, very common, where you have a client-server architecture, even on the operating system. For example, the display server X is what shows windows and makes things get drawn on the screen, is a server, and applications are clients of that window server to make stuff show up on the screen. So CSRSS is, and you can imagine that interaction between applications that may be running just as like a regular user process, but now that needs to draw something on the screen, oh my god, that's like a big deal because it has to interact with the hardware, right? That's a privileged set of operations. How does it make that transaction? It's going to be through this intermediary process, and that's some of what CSRSS.exe is doing. Okay. So what other two processes does smss.exe start? We know that it starts off csrss.exe and wininit.exe. No? Am I... Oh, winlogon.exe. Maybe it's winlogon.exe? Oh, they're asking for session 1? They are, yeah. So the csrss.exe and winlogon.exe. There we go. And winlogon.exe does what? The Windows logon process, and I'm again quoting from sysinternals, handles interactive user logons and logoffs. Winlogon.exe is notified of a user logon request when the user enters the enters Control-Alt-Delete, basically. But so yeah, winlogon.exe, important to note that it handles interactive user logons and logoffs, not necessarily non-interactive, like service authentications, things like that. There has to be hands on a keyboard in order for winlogon.exe to enter the picture. Oh, cool. We get a deep dive into the client-server runtime process, or subsystem. The process is also responsible for making the Windows API available to other processes, mapping drive letters, handling the Windows shutdown process. So, and you'll see this often in operating system architecture, where there's a set of privileged things that has to happen, and then the operating system kernel, where there's all this power to do some real damage, and then of course you have user applications that shouldn't really have that much access, but to do stuff like connect to the network, or interact with hardware, or interact with memory in a certain way, they're going to need to have some level of privileged access. How does it happen? It happens through these intermediary levels, like csrss.exe. So let's take a look at csrss.exe in Process Hacker. Okay, running from System32. The command line is interesting. It's running a system as well. Can we get a... I guess we don't need a parent PID because it's in the tree here. Right, so this one's a child of 0. All right. And remember that csrss.exe and low-end-logon are called from smss.exe at startup for session 1. And remember, smss.exe dies, right? It terminates after it spawns both of these. What was the process which had 384 and 488? That can't be, we can't be looking at that live. So was it just in the text here? Oh, non-existent. I see. So what was the parent? 384 and 488. So they're asking what spawned these two instances of CSS or CSRSS. That is difficult for me to say. The session manager subsystem. Alrighty. Now I kind of accidentally got this one before, but this is win-init.exe. Let's talk about this. The Windows initialization process is responsible for launching services. Services.exe and LSAS, my best friend, and LSA ISO. Yeah, it's a credential guard thing. But let's again get some extra detail from the source about win-init.exe. The win-init.exe process performs the following system initialization functions. It marks itself and the main thread critical, so that if it exits prematurely and the system is booted in debugging mode, it will break the debugger. Okay. This is a lot more detail than we need here as I'm looking through this. But interestingly, win-init is responsible for creating the temp directory as C Windows temp. That's kind of cool. It also sets the machine name. And, right, as mentioned, it initializes the LSAS, LSA system and any encryption keys. And then waits for shutdown. It's pretty much what it does. By the way, I'm going through this room, right, and I'm, trying to brush up on my Windows basics as well, because, the truth is, even if you do this on a daily basis, there's so much to know that refreshing your fundamentals is always a good idea. It's just like, again, I was a martial arts instructor for a long time. You still got to train the basics, right? You got to build that foundation, work on your horse stance or, your basic jab cross if you're a boxer. Have you ever seen lsas.exe being spawned twice from win-init.exe? I haven't. That doesn't sound like that should work out because lsas is... It's hooking into too many things, right? If you have two instances of it, you have some unexpected consequences there. Yeah, Richie, I have to say, as a Linux person who's trying to be as good as they can with Windows, it's It's very, very difficult. And in part of it, it's just the age of it. And it's also, the diversity of things that have had to be included in Windows. So what would be weird for WinInit? Again, an actual parent process, something other than Windows System 32. By the way, I should point out that if you ever see any of these kind of Windows processes and they're running from not Windows System 32, that's something to be alarmed about. And often you'll see processes that try to almost typo squat with these, and you want to be aware of that as well. Yep, subtle misspellings to hide rogue process in plain sight. So yeah, just be aware of that. And multiple running instances. And then, which process might you not see running if credential guard is not enabled? LSA ISO. So this is really cool. We're basically walking through the startup process for a Windows system and what we should expect to see. Right? Next comes services. And as you saw, services are, privileged processes that are, running in the background on a Windows system. We saw them in Task Manager. Here, there is also a specific services. If we click Open Services from any of this, it'll actually open the specific services viewer, which gives us a little bit more detail. There was also, as mentioned, a command line way to look at services. We have sc.exe query, which will list all of our services. There is also, that's the old school command line way of doing it. I'm pretty sure there's also a get service. Yep, sure is. So if you wanted to do it PowerShell style, you would do it this way with get service. And of course, you can get service name when defend. I'm pretty sure that'll work out. Yep. So if we wanted to select a specific service and get more information about that, we could do it that way. And if we wanted to get all the information, we could pipe it to format list, or shorthand that, pipe that to FL. And by the way, putting on the red team hat for a second, one thing that I might be looking for if I get onto a machine with limited privileges, right, as not system or not as administrator, I would be maybe looking through these services for any service that I have control over, whether I can shut down and stop it, and if I could change where it's located. If I have control over the bin path, I might be able to do something really interesting with that. So, replace it with my own malicious code. So, just as be aware of that services can present an attack surface for the bad guys. And yes, information regarding services is stored in the registry. Navigating the registry is kind of its own thing in terms of, learning about Windows. It's not really what this room is about, but boy, definitely worth spending some time understanding what the different hives are about, right? Current user, local machine, things like that, and understanding where you might likely find different values, because there's so much in there. Backing up for a second, what is the Windows registry? We talk about it all the time, and you may even have seen debugging or troubleshooting instructions that ask you to open up the registry editor. But what is it? The registry is the database that backs Windows. Think, we talk a lot about on our Wednesday coding sessions about application state. And application state, if you think of the operating system as an application, which in many respects it is, it has to store its state somewhere, and it has to store how it's configured. Now, on a Linux operating system, a lot of that stuff is stored in plain text files. Well, Windows made the decision to go a different way and use a registry model. So these values are stored in a registry, which is itself binary data, but can be accessed using specific software like the registry editor. And it's structured in this tree method for these different kind of classes or hives of information. Yeah, good point, Angel, about classes root. So when a user logs into a machine successfully, this process, meaning services.exe, looks at the last known good configuration and uses that. And this is where I start to go crazy with how Windows handles services. Let's switch up the music to something a little bit less lyric-y. So what am I talking about? So if we look at Process Hacker, you can see that services.exe has a ton of svc host.exe children. And this is how services get launched. svc host.exe hosts, literally, whatever the service happens to be. The problem is, very often, it's going to be svc host.exe that gets logged as what's doing something. And that can be a huge pain. So you want to be careful about your parent-child relationships with these different services, because learning that svc host.exe did a thing is not super helpful. But learning what its child process was, that can be very valuable. Right? Each one of these may have something in here that will be of value to me. Right, so con host, right, that's a connection host, or the console window host, yeah. Same thing, where it itself, or compattel runner, what's really going on under the hood is the child of that. So let's get back to our... So what's normal for services? Again, we're running from system 32. Its parent should be WinInit, and it, of course, is also running as system. How many instances of service.exe should be running on a Windows system? And then we go down one level to svc host, which is a little bit more complicated. The services running in this process are implemented as DLLs. The DLL to implement is stored in the registry for the service under the parameters subkey in service.dll. So let's actually dive down onto that one a little bit. So let's take a look at an svc host.exe example. Let's do RDP clip, because this is actually kind of a neat one. So RDP clip is handling the clipboard operations for a remote desktop process, or a remote desktop session, which is what we're in right now. So let's look at it in... I actually want this, I want not RDP clip, I want actually the svc host instance, and I want to see the k-term services. And here are handles to it. Let's go back to... Yeah, let's actually fire up control set services. So let's go take a look at the registry editor real quick. Take your time. There we go. And we're going to go to HKeyLM. And, God, I just blanked on it. Yeah, system current control set services. System current control set services. Now let's take a look at RDP clip, if there is one. There isn't, but that's not actually what we saw. What was it? Term services, right? Because it's part of terminal services. Term service. So there's the image path, which matches what we saw here. And then here, these are the DLLs that are actually getting loaded. Alrighty. But you can see all these other services that we have information for as well. And so something to be aware of with any Windows services is, you know, again, bizarre or perhaps unprivileged paths in our DLLs that are getting loaded for a service. That might be something to be aware of. Oh, this is cool. So we can go to service and go to service. Oh, neat. Let's do that. Let's just learn how to do that thing. So service, go to service. Cool. And then we go to properties on the services here. That's nice. Okay. That I did. So in the binary path, there's a -K flag, and that's how services should be called. So again, normal stuff, running as system. Parent in this case is not, you know, blank or something that's been exited. It's services.exe. Running from system32. That's right. The user account will depend on what's going on. It might be network service or local service. But it definitely won't be like a random user. What? In Windows 10? Okay, my bad. Some in Windows 10, some instances can run as the logged in user. That's confusing. So we want to look for that -K parameter in the binary path. And again, misspellings. What single letter parameter should always be visible in the command line or binary path? K. Which is what's connecting it to the DLL. All right. LSAS. The Local Security Authority Subsystem Service. Now, I know that there are at least a few pages on this in the Windows Internals book because there's so much going on within how authentication takes place. This thing enforces the security policy on the system. right? So we're talking about authentication, any password changes, and creates access tokens. It also means that credentials are stored in this process's memory, which is why it's such a tasty target for attackers. And if you've heard of Mimikatz, this is what Mimikatz is going after. Or, that's not all Mimikatz can do, especially these days, but it's definitely part of what it does. I swear I didn't read this stuff ahead of time, but it's always nice to see that what I'm just sort of spouting is exactly what they've decided to comment on here. Again, let's take a look at what the book has to say about lsas.exe. See if there's anything interesting. There's so much in here about how LSAS works. I know there's like a whole security section in this. Scythe, thank you so much for the follow. You see services running from 30 bits to 64 bit. So, Angel, I want you to try to explain that as though somebody who isn't super familiar with Windows internals is reading what you're saying. I think that's important information, but there's a lot of kind of inside baseball inside that explanation. Trying to get to the... I have a feeling that this room was taken basically directly from the book. So, talking about what LSAS does. Yeah, I think this is the best bit here about what LSAS is. So, LSAS. This user mode process runs the image lsas.exe that is responsible for the local system security policy and sending security audit messages to the event log. The local security authenticator service, which is the DLL, is a library that LSAS loads, implements most of that functionality. So, there's a lot that LSAS is responsible for here. So think of older software that's written 32-bit. Now Windows is only 64. The company still wants to run 32-bit software. So what we do when making installation packages is to trick the operating system by virtualization. Right. And how does it do that? This will make the OS think it's located and working as a 64-bit architecture, even though it's written in 32-bit. So, right. And how does it do that? What does WOW stand for on this case? It's not World of Warcraft. So the only question here is what is the parent process for LSAS? Win-init.exe. So the files are stored in 32-bit. We hijack the API call and then redirect it into another location where our files are. That's right. The way that happens is something called Windows on Windows, or WoW. All right. Now we're on to winlogon.exe. Yeah, so if you ever hear SAS in this particular context, we're not talking about British Secret Service. We're talking about, or British Special Operations, we're talking about Control-Alt-Delete. Written here as Alt-Control-Delete for some reason. But yeah, we're talking about Control-Alt-Delete. WinLogon is listening for that, or some invocation of that. That's a really good explanation, Angel. Thank you. This process is also responsible for loading the user profile. nt.user.dat is an important file, obviously, but this is where your stuff lives. Not your credentials necessarily, but the user's profile. Let's take a look at this link, see if there's anything useful to learn about here. Right, user init specifies the programs that WinLogon runs when a user logs on. It's also doing the screen locking, screensaver, all cool things like that. Because it's kicked off by SMSS, if we remember back to a couple of blocks ago, it doesn't have a parent process. Hey, Oreo Bite. We're just getting some ASCII art in here. So WinLogon should not have a parent process. It shouldn't be just all of these, right, have kind of the same detection rules for weirdness, right? If they're coming from not system32, if there are typos that are trying to hide as one of these processes. And this is a big one, shell value in the registry other than explorer.exe, because then something else is going to get kicked off when the user logs in. What is the non-existent parent process for winlogon.exe? We learned that because we learned what kicks it off, smss.exe. Almost done with this room. This room definitely feels like homework, but I think it's, again, super important to understand this. I have to tell you, again, I'll reiterate, especially for the new folks who just showed up, if you're interested in working as a SOC analyst, if you're interested in doing blue team work, knowing your way around the Windows operating system, it's like, you know, knowing your way around a big city and being the local, or being able to behave like a local, so you can understand what's supposed to be there, what's weird. It's like street smarts, but for a computer. Any scheduled tasks? I'm pretty sure we're going to get to that, not in this room, Angel, but definitely in this course. And Orbital, thank you so much for the gift sub to Angel. Orbital continues to be our generous benefactor. And lastly, we'll look at explorer.exe, everybody's favorite. This is the process that gives the user access to their folders and files. Yeah. I mean, it does a little bit more than that. Explorer.exe is what makes the desktop show up too. I mean, it's your entire, you know, essentially the GUI for Windows, right? It doesn't draw windows. Well, right, it's the thing that always crashes because it's handling so much of what's going on. What I mean to say is that Explorer.exe is not just these file browser windows. Explorer.exe is also the taskbar. It is also the system tray. It is also the desktop itself, right? So that's why so much is going on. And that's why it has such a potential to go bad. Let's take a look at Explorer.exe in Process Hacker. Right? It doesn't look as though it has a whole lot underneath of it, but there's a lot underneath of it. Oh, I don't know. I have to say, I don't know which one crashed on me more often, Explorer.exe or Finder on Mac. I have, at different points in my life, used as my daily driver both Mac OS, Windows, and Linux. On my main machine, I run Linux most of the time, and I have to tell you, it's more stable than either of the other two. My desktop never crashes. All right. So what kicks off user init.exe exits after spawning explorer.exe? So Explorer is spawned by user init, so something to keep in mind. And the winlogon process runs user init.exe, which fires off whatever lives here in the registry. So if this gets changed, right, something else will happen when a user logs on, and that is a persistence vector for attackers. And yes, there will be many child processes for Explorer, because this is it. You know what? Here's a good way to think of it. Explorer is your shell. Explorer is the shell. And so that's why you have all these child processes. Anything that you start up will be underneath of it. Now, this is the first one we've seen that won't necessarily be system or a privileged user. This one, Explorer.exe, will be running as you, right? So if we take a look at that, let's take a look at the token here, right? It's logged in as me, and you can see that this SID is super, super, super long. There's a lot of information in here, but you want to focus first on the last bit of it, which is the user ID, right? And 500 is going to be the built-in administrator most of the time. So yeah, Explorer is not necessarily elevated. Right, the RIT. Again, you want to look for weird parent processes. Explorer is a process and not a service. That's right. All right, what is the non-existent process for Explorer.exe? Chat, I'm going to have you try to answer that one. See if you remember what we said. What process launches this thing and then exits? Is it winninit.exe? Nope. User init. There it is. Oh, dope. We knocked this room out. But yeah. Nice job. Yep. Angel finished out the room. Not even one we're in. Yeah, you don't get that one as a defender so often. So again, let me strongly recommend getting the Windows Internals book. What I might do, boy, here's an idea. I might do a giveaway for the Windows Internals book at some point. I'll buy an actual copy and think about mailing it or something, just because it's such a good asset. And I know it's expensive, but it really is. I read it through the first time like a novel, and no, I didn't internalize all of the wisdom inside of it. It's just too much. It's also like, yeah, Amazon gift. That's a good idea. Oreo bite. No, I didn't internalize all the wisdom inside of it, and I've only done volume 1 and volume 2, but after reading it through, it was like Neo in the Matrix, right? I know Kung Fu. I was able to much more deeply understand what was going on Windows, and then when I was looking at forensic artifacts, it was much easier for me to get what was going on. As much as I hate linking Amazon, it really is like the best place to get this particular book. Real useful. Yeah, it's how many pages long is it? It's like, yeah, it's 784 pages for whatever metric that is, but it's a beast. Absolutely it is. But as you might be able to tell from the authors, these are the folks who know. They were there when the old magic was written. It's amazing how much skill you can emulate just by reading. Taking the time to read the documentation. Doing your homework is essentially a superpower in this game. Excuse you. I definitely just did that. All right. That's right. Mark Russinovich did not begin his career. But you're illiterate. You're doing a great job of writing for being illiterate. And also, that's what I'm here for. Do you think it would Cinder Remedy, do you think it would make more sense to get the digital copy using it as a reference manual actually front to back? I think that depends on how well you process information. So I think there's value in both. I have the digital version because I spend most of my time looking at a screen anyway. But if you want to read through it and you read better on a paper book, then I think there's an argument to be made for both. I really do. I have the digital version, and I do happen to agree with Angel. It's easier to search through. But I would say that also it would be a good thing to have on your bookshelf in the DIFA room or whatever in your office, so that you can have a reference there when you need it. All right. Let's get started. Since we were talking about sysinternals, let's go through sysinternals. Yeah, here's a little bit of history about the sysinternal suite. They were created by Mark Russinovich back in the late 90s, along with an individual named Bryce Cogswell. In 2005, Microsoft acquired WinInternal Software, and Mark joined Microsoft. And today he is the CTO of Microsoft Azure. Since our backdoors and breaches game, I've been digging into Kerberos and attack vectors and RFCs. Yes, it is. It is a jungle. All right. We get this IP in 2 seconds, but I think we're going to give it a little bit more time just to allow the Windows machine to start up. It usually doesn't start up as quickly as they'd like to believe. And so what are we going to start with? When did Microsoft acquire? This is just reading comprehension. When did Microsoft acquire sysinternals? 2005. And yes, I have deployed the virtual machine and I'm ready to move on. All right, let's see if this thing is ready for us. Nope, not yet. Give it a little bit more time to bake. And okay, well, I have the sysinternal suite, but yep, maybe we will. I don't know what they have in store for us. This is just installing sysinternals. What's the last tool listed within the sysinternal suite? Well, zoom it. Yes, I am using a Linux host to connect to the machine. This is my Kali machine. I just, the reason I'm doing that is that I have the TryHackMe VPN connection in my VM rather than my host, right? And the truth is that they're going to be giving me a Windows machine here anyway, so I'm not too concerned about performance. There we go. Administrator. Let me in. What was it? 1, 2, 3! Exclamation point. Yes. And we'll update our resolution here. Oh, cute. All right, so all right, we're going to extract the sysinternal suite. And I'm going to fire up a PowerShell window as an administrator so that we have the ability to look at anything that we need to look at. And same deal. Make the font a little bit bigger for us. Oh boy. Okay. I don't remember, Angel, if there was another full set in Wind Internals. I gotta tell you, in 2005, I was not doing this stuff. This window is too large. Oreobyte, I have been doing IT for, good lord, since 2008. And I have been doing information security primarily for about 2 years. But before that, I was, the director of technology at school, at a school, or a series of schools actually. And so I was responsible for everything from network engineering, deploying virtual machines, deploying actual assets to people, and of course network security, endpoint security. I was kind of doing everything, even making my own network cable and running patches and handling switches and all that stuff. There's so much to do. There's so much to learn. You're never really done. Okay. I want to go to the desktop and the System Internal Suite. There we go. Yeah, I truly believe that being a generalist is really a nice background to get started with security, just because you understand how things are for real users. That's one. And you never know what you're going to encounter in security. You never know what kind of problem you're going to run into. Perfect example. Yesterday, I had a situation where there was an escalation from, a desktop support alert, and they got to us. And there was a concern about a virus on a computer. And that's usually the language that you hear, a virus on a computer. That's kind of a big deal. There's a technical definition for a virus. We don't necessarily believe that there's code getting injected into a process. We don't know that yet, but there's something going on in the machine. So we take a look at it, right? We do a remote into the machine, and sure enough, we see that there's this evil pop-up. It looks like they've been infected with something. But, and this is the important part, if you look at the screen, right, carefully, you can notice that there's something a little bit off about it. And what was going on was that it was a fake pop-up. It was a fake browser pop-up that full screened the browser window so that it looked like a fake desktop, and it was trying to emulate Windows, right, with the X and everything, but it didn't do it perfectly. And consequently, my first thought was, oh, okay, this is the first full screen browser pop-up, just because I had that experience before, and pressed 11 to unfull screen the browser window, and sure enough, it was like this: the user had clicked accidentally on an ad, and the ad had taken them to this thing. It didn't download anything, it wasn't anything else, but that particular bit of knowledge about full screening the machine, or full screening the browser window, can be very alarming to end users and even inexperienced desktop support techs, just because it completely changes your experience of what you're seeing. But yeah, having been around the block with those things a few times really, really helps. Yeah, absolutely. And by the way, I'd also point out that in that particular interaction, the most important part of that interaction had nothing to do with technicals. Once you are brought in to deal with an issue like this, your first job is to make the user feel safe. Even though we spend a lot of time talking about technicals, and we're talking about, Windows internals today, it is all in service of people. If you forget that, you are not going to do this job well. If you want to work in information security, your motivation, obviously it pays well, and that's great. If you want to provide for your family, if you want to further your career, that's awesome. For me, though, all that is true, but for me, though, I am here because, in a very deep way, like, the thing I want to do more than anything else is help other people. And if you feel that way, and you're in this industry to do that, it takes some work to keep that at the front of your mind as you dive into these technicals. And it's easy to get frustrated with users who don't know what you know, and who don't interact with a computer the way that you would want them to. It's easy to get frustrated, but empathy has to be at the front of your practice, because at the end of the day, if you're not if you're not making people feel safe with their interactions with you, they are in fact less safe because they're not going to be willing to come to you with problems. That's an issue. So once you're engaged in this way to help address an issue, the technicals matter, but the first job is to make the person feel safe and that they are protected, and that once the engagement is over, once the issue has been remediated, that they feel empowered to do something to protect themselves moving forward. Yeah, so it's tough, especially internal, like if you're working with engineering teams or operations teams where security is kind of like a price that they pay for doing what they're trying to do. It can absolutely be difficult to make them feel that way, and different organizations are obviously structured differently. It can, yeah, we don't have time to patch, leave us alone. That's very common. That's a culture thing, right? It can be difficult to build those relationships, and it really is all about building relationships at that point. I don't have all the answers on how to do it. But I think leading with kindness is probably just the first thing. And having a service attitude about it, really, so that security is there. Security only exists because of what the business is trying to do or what the organization is trying to do, right? They are your customers. And so if they're being, it's not a great relationship if they feel like they're being hampered by security, even though some of what security is going to be asking of them is going to be inconvenient. Hey, Security Live. Good to see you. All right, I'm going to step down off the soapbox and fire up some of these sysinternals here. What are we doing? Good lord, this thing is long. For the sysinternals website, sysinternals live. Oh, that's wild. You can run sysinternals from... That's neat. Right. Will that work in a PowerShell window? I think maybe not. I have no desire to do this if we have procmon already on the system. But that is cool that you can just mount the drive. But honestly, I would prefer to just have my own media. See that live sysinternals.com, a lot from pentest engagements. Yeah, and again, don't pentesters don't give them anything easy. Let's just procmon 64.exe accept EULA. Procmon. Wait, the filter excludes everything? There we go. I was like, that seems incorrect. Let's make the font a little bit bigger, again, so that you guys can actually see what's going on. Boy, Arial does not scale well, does it? Or whatever this is. Sans serif. So this is every process. And what we're seeing is what the process operation is. That's what procmon is showing us. So you see a lot of read files. You see a lot of registry access going on. Here's some Explorer stuff, accessing registry stuff, network as well. So if we wanted to filter down into network, we could do that. I like doing that. Filter operation is, and we don't have to type it manually. We can actually pick from a list here. So we'll do TCP send if we want to see what's talking. I always forget to hit add, but yes, that's what we want to do. You can see where it's going. And of course, what the PID is. A lot of service host. But this is where, you know, this is where Process Hacker or Process Monitor plus the Process Explorer plus Process Monitor comes in handy. Because if we look at this, let's take a look at PID 628 with the Process Explorer. Yeah, procexp 64. And we're going to go look at that PID 628. We'll see that this TCP send, you know, it's not just SVC host, something is doing it. And what is that? We can see that it's from term services, right? If we look at it here. And this is just the properties from Process Monitor. But we can go look at PID 628 right here. Yeah, there's term services. So a little bit easier to see in this particular area what it is. Okay, what are we doing? We're supposed to be... Yep, and the stack tab, we can dive deep into the syscalls done on that event. Yep, absolutely. What service needs to be enabled on the local host to interact with live.systeminternals or systeminternals.com? WebDAV. No? Web client. Okay, let's take a look at our files and disk utilities. Hey, if anybody from TryHackMe is watching, feature request. When I expand a new component of a room, could you, or if I go from the bottom of one and then I go to the next one, could you please scroll me to the top of the next section? That would be nice. All right. Each task within this room will focus on one or two tools. Okay. Signature check is a command line utility that shows file version number, timestamp information, digital signature details, including certificate chains. It also includes an option to check a file status and virus total. Handy. So if you have a suspicious binary, that would be something you might want to check out, is use sigcheck. I'm going to check for unsigned files with -u. This thing doesn't have access to the internet, does it? No. It's like, yeah, live, that's why the live sysinternals doesn't work, because we don't have access to the internet on this thing, which is fine. Like, why mention it? Okay. So if we had a malicious binary on here, let's give it one, actually. we're connected to the VPN here. Let's go ahead and give it some evil. It doesn't have to be anything fancy. Let's do a little MSF Venom. Yeah, I'm still 10.13.720. Okay, and gonna lhost equals tons. So Oreo Byte. I know it's supposed to, but for me it does not. I've tried it a million times. I don't know why that's true, but whenever I try ton zero, no, it's a good call out though. But for whatever reason, I need to provide it the actual IP. Yeah, exactly, Angel. What am I doing? HTTP server. Yep. Going evil for a second here. Incredible. Okay. All right, so now that we have this evil binary on here, we can use sig check against it. And what was that shortcut for accept EULA? E. Yeah. So we'll do, oops, E, C, users, administrator, downloads. Sure enough, this looks bad, right? It's unsigned with no information about it. So, Spire Chill Detector is enabled to show files that are unknown, and then E is scan executable images. Yep, totally legit. Ugh, God. Alternate data streams. Somewhat fallen out of favor, but still something that's worth learning about. I don't, like... Can someone please tell me why alternate data streams exist other than for nefarious purposes? I seriously can't figure it out. It was like, okay, what if we made files able to hide other files for no reason? Let's put that inside of the operating system. Every file has at least one data stream, and alternate data streams allows files to contain more than one stream of data. Yeah, a file downloaded from the internet has this data, this zone identifier data, which is interesting. That's it. Yeah, that's another one, the XP command shell. So that one I can almost understand a little bit more, just because it's like some engineer needed to run shell commands from something that they were doing. And they're like, I'll just put this in here. It'll be fine. because I need it, and I'm not thinking about the security implications of it. Oh, sdelete is secure delete. That's cool, right? Following DOD 5220.22-M. You can put Windows XP on the DMZ as long as the internal side of the DMZ is made of freaking depleted uranium. So when you wipe disks to give away, this is how you're supposed to wipe them, right? Where you write a 0 onto the sector, or not the sector, but basically write a 0 where the bit is and successfully verify the write. Writes a 1, so flip it basically, and then write a random character to it. This guarantees that you're not getting your data back, essentially. We're obviously going to be using streams against the file.txt. So, and by the way, yeah, always, this is like elementary stuff, but for the love of all that is precious and holy, do not allow any policy on your machine or in your environment to hide file name extensions. I don't care if it doesn't look as pretty. Everybody should know whether a thing is a PDF or a PDF.exe. Gitsall, thank you so much for the follow. And the way that you do that is you teach people to recognize the file extension. Not the pretty icon. All right, we're gonna run streams.exe against file.txt here. Okay, so it shows us that it was downloaded from the internet. And oh, we want the -s to, oh no, not recurse subdirectories. Can something appear as a certain extension but actually be a different file type? Not sure that. So the file extension is going to be the file extension, but depending on the type of file it can be. So for example, an application like an executable file can have an icon, right, that makes it look as though it were a PowerPoint file or a PDF or something else like that. So you can disguise it in those ways. There are often attacks where it'll be like .ppt or .pptx.exe, where it's, you know, it's kind of looking like a PowerPoint file, so you double click on it, something happens. That's one way of disguising your files. And then of course the other way is these alternate data streams, where, you know, maybe you don't need the user to click on it, but you need the data to be accessed. So, for example, you know, let's say I downloaded a text file, but the alternate data stream was an executable. And I have another, like a macro-enabled spreadsheet or something that is able to extract that data. Now, the user's not going to be doing that, but the code that I wrote as an attacker will do so. But if I'm after the fact, if I'm investigating, that's going to be very hard to figure out unless I'm looking very carefully at that macro. All right. Let's see here. Yeah, I want... Let's go. Yep, that's what we want. We want get item. Is that wrong? ADS.txt. There we go. Thank you, PowerShell. This is how we read alternate data streams. You get the item. Now that you've used streams.exe to identify the data stream, you select the stream, and then you pipe it to get content, which will get you the text. That's how we do that. All right, let's look at TCP view. I love TCP view. Oreo Bite, I have done many of the red team rooms. Yes, I have done several. On Tuesdays, we do red team stuff. On Saturdays, we do blue team stuff. And on Wednesdays, we do programming. What my day job has become, even though I'm technically a security analyst, is that I do a lot of the adversary emulation and web app pen testing for my organization. So I have a finger in both red and blue team pies. Which is fun, because I don't want to have to choose. I think that both skill sets are valuable for both specializations. Again, I think about it a lot like martial arts, right? I mean, I can't defend if I don't know how to throw a good strike, and I cannot land my strikes if I don't know how defenses work. Right. TCP view. Let's kick that font size up again. That's nice. So this is everything that's phoning home. Now, some of this is going to look a little bit like what you can get with the netstat. Look familiar? Now, if we look at netstat/h, right? It'll tell us all the other things we can get with netstat if you're interested in using it this way. I like displays all connections, O for the owning process ID, P for the protocol, and yeah, AOP is usually what I go with. So if I do netstat-AOP, how about OP? AP? The hell? I can't get the process ID. That's weird. But I can certainly get it from here. But notice that netstat-A actually shows me a lot more. These are, I believe, outbound. No, those are... Yeah. Whereas these are listening connections. Right? So you can see that I'm listening on 135.4.4, RPC, SMB, remote desktop, WinRM. Right. So if we unselect show unconnected endpoints, we'll see more. Or reselect it. That's better. Using Whois tools, what is the ISP organization for the remote address in the screenshots above? (52.154.170.73). Who is 52.154.170.73? Microsoft. Wait, what are we asking for? I mean, it's the Microsoft Corporation, right? Cop rotation. Corporation. Process utilities. We've already gone through some of these, but let's also take a look at auto runs. This is a great one when you're doing an investigation on a machine to see easily what has been configured to start when the machine or the machine starts or when the user logs in. Real handy to be able to check this out. I'm just so happy that my stream is not dying after 2 minutes or 2 hours and 3 minutes anymore. Having fixed that router issue, we're no longer getting big Fs at that exact time. There you are. Took your sweet time opening their auto runs. And so this this user interface obviously came from the early 2000s and has not updated since. So what are we looking? This is the everything tab, right? It'll show you the whole smash organized by kind of category, right? You see registry stuff here and it's still loading, as well as scheduled tasks. Angel, you were asking about that earlier. Everything that's configured to start when the machine starts or the user logs in. And then we can filter it down if we want. If we click on scheduled tasks, it'll show us just those scheduled tasks that are set to start. Process Explorer is one of them. But so is the EC2 launch instance initialization, because this is running in Amazon. Google Update. Is there Chrome on here? Yes. So when you install Google Chrome, little did you know, you also install the Google Updater that runs this way. So this is something that you would expect to see when you install Google Chrome. This isn't weird. It's kind of gross, but it's not weird. Let's go to just everything. So note that alternate shell is set to cmd.exe. Paradox 109 Chrome software reporter tool is really gross. Yeah, install as user, but if you deploy it as per machine, you normally disable that behavior. Yes, you're supposed to disable that behavior, Angel, so that you don't have the auto updater. Not everybody does that though. All right, we're supposed to do something with this other than look at it. We did proc dump. Its primary purpose is to monitoring the application for CPU spikes and generating crash dumps during a spike. Yeah, I guess. So Process Explorer and proc dump kind of, we talked about this. Right, Google does have a business package that disables it by default. I want to call this out though, very, very importantly. And Angel, I think you know this too, which is that, you know, there's the right way to do these things, and there's like the business safe way of doing these things. And when you have an enterprise IT staff, you can do that, or you have folks that are, you know, trained on how to do this. They're certified as Windows system administrators. That's great. There are a lot of small businesses. Forget a user can install it if they will. There are a lot of small businesses, and what does their IT staff look like? It's one person. They have the IT guy. They call Bill when the printer breaks or when they can't get on the internet, the Wi-Fi's down. Like, there's one guy. And that one guy may not be a domain administrator or not properly, right? And there's lots of ways for small businesses to get hosed by the enterprise way of doing things if they don't have access to those tools. You think the restaurant down the street has SCCM configured? You think that all their group policies are set the right way? We have to think about those areas as well, not necessarily just the blessed enterprise way of doing things. And it's in those gaps where a lot of people really fall into trouble. Companies back up everything. We just had a news story I didn't report on, but that we saw today was that Synology, which is a pretty reasonable backup solution, right? Had multiple RCE vulnerabilities that just got disclosed. Hey, Angel, I mean, Shadow IT is a problem. Shadow IT, for those of you who don't know the term, is IT getting done by people who know computers but aren't necessarily authorized to make changes to systems, right? I'm not even talking about Shadow IT. I'm just talking about IT without any sort of formal training or without a proper budget or systems to manage. You know, my experience in schools really brought me to this place because I spent a lot of time working with machines that were donated. I spent a lot of time working with machines that I refurbished, and I didn't always do things the right way. I'll admit that. In some cases, I had to learn it myself, or in some cases, I just didn't have the resources to do it the right way. I'll give you a perfect example. In 2010, when iPads came out, schools bought them in droves, but there was this lag between when iPads came out, even the iPad 2, which came out in like the year later, 2011, when iPads came out, and when the management tools that made them make sense for schools or any organization that was trying to deploy them at scale came out. And until then, what did you have to do? You had to use this horrible tool called the iPad configurator, where you had to plug in individual iPads to this thing to deploy the applications you wanted to deploy, and like manually copy and paste these spreadsheets of app codes to get the apps that you wanted on there. There was no centralized management of anything. It didn't exist yet. But because the product existed, schools wanted to use them with their students. And of course, forget cloud storage of anything, right? Kids were storing their documents on the iPad, and we had to figure out ways of getting them off. And then printing, forget about it. I could go on a huge rant about the iPad situation in the early 2010s, but the point I'm trying to make is, for every enterprise that is doing IT management and system configuration the right way, there's 100 small organizations that are doing it the best they can, but they have a lot of gaps because they don't have the resources, whether personnel, training, or materiel, in order to do it the right way. Polycarp, thank you so much for the follow. All right, we've done Process Explorer, so kind of want to jump past this one since we've done Process Explorer a lot today. And Procmon we just looked at as well. PS exec, okay. There's a lot in here. So PS exec, by the way, is basically just evil at this point. If you see PS exec getting run on your in your environment, make it stop. Make your admins who are still using PS exec stop if they are. There are other tools you can use. Complete with full interactivity for console applications without having to manually install client software. PSExec's most powerful uses include launching interactive command prompts on remote systems and remote enabling tools like ipconfig that otherwise do not have the ability to show information about remote systems. Yeah, PSExec gets its own MITRE technique shoutouts. Run auto runs and expect what are the new entries in the image hijacks tab compared to the screens above. Let's go take a look at image hijacks and see what's there. Well, what was in the screenshot above? Oh, Lord. Just Internet Explorer, so what entry was updated? Task Manager? What is the updated value? All right. I'm chuckling because like Sysmon is probably the most important one on here, and this is the shortest section we've seen so far. Sysmon has its own room though, so don't worry. Next week I'm pretty sure we'll just dive into Sysmon and everything that you can do with it and what we need to do to configure it well. Let me put it to you very, very simply. In a modern environment, you should have Sysmon configured on your Windows endpoints, and the data should be going somewhere, to your SIM, probably, if you have a SIM set up. If you're not, you are missing, I think, the best source of evidence for threat hunting and for incident response and digital forensics. Obviously, but filtered. That's why I said configured correctly. But you need to have Sysmon on your Windows endpoints because it fills the gaps for what Windows event logging doesn't have in there by default. All right, now we're looking at system information tools. So WinObj is a 32-bit Windows NT program to look at the NT Object Manager's namespace. Let's fire that up. Goodbye, auto runs. Yep, I think we're digging into named pipes among other things. Just nothing here. Well, we still want to see what... Okay, so WinObj, what does this look like? There's a lot to see here. We have devices, we have drivers, we have driver stores, we have stuff in the file system. We have security stuff. We have sessions. I'll be honest, there's a lot of stuff in WinObj that I'm not super familiar with. But as Angel said, a lot of what we're looking at here are these things called named pipes, which are named, essentially data channels that applications use to communicate. Yeah, it can't be opened. Can I look at properties for these things? Nope. This is helpful if you have a thing that you specifically want to look for, and I think, DLLs are going to be a huge part of what you want to look at. So, for example, if you had a DLL that got loaded and you didn't know what it was all about, this would be a place to check that out. Good old crypt32. All right. Moving right along. Just miscellaneous. Oh, this is cute. Yeah, you can make BG Info show stuff on the computer's desktop background. Strings. Strings is good. So strings is the Windows equivalent of the strings command on Linux, which you can use to, quickly look at ASCII or Unicode encoded strings inside of binary files. Super handy. Run the strings tool on zoomit.exe. What was the full path to the PD file? Okay, so we're gonna do that. To do that, we have strings.exe. Nope. Strings.exe, and we'll do zoomit.exe, and we're gonna pipe that to select string, pattern. Oh, for the love of God. Select string drives me crazy. I'll just use find stir. What was the full path to the PDB file? Did they want Win32? There it is. Okay. There were 2 of them. All right, that was a nice little tour of sysinternals. That was fun. All right, so as we move forward in this course, this path, we're going to have a lot of opportunity to use these tools. And when we finish that up and we get back into other blue team stuff like malware analysis, reverse engineering, we'll play around with some of this as well. So enjoy sysinternals. Again, if you can afford it, I strongly recommend checking out that Windows Internals book. And I'll put some thought into maybe doing a giveaway. Lastly, before we get out of here today, something I did notice is that Google is running a beginner CTF today. So if you wanted to check that out, head over to capturetheflag.withgoogle.com/beginnersquest. I'll be doing some of that today, I think. So that'll about do it for today. I know this was a bit of a long one, but hopefully valuable. OreoBite, what books are best to learn more about AV evasion and Active Directory? Well, start by learning about Active Directory. And I actually... Thanks, Angel. Thanks for hanging out. I actually wouldn't point you to a book. I'm actually going to point you to another content creator, Heath Adams and Joe Helly at TCM, the Cyber Mentor Security Academy. They have these amazing courses that'll teach you all about this. So So OreoBite, these are like the cost of books, right? $30 a piece. But if you're looking at Windows privilege escalation and then movement, pivoting, and persistence, I strongly recommend checking these out if you want to get better at things like navigating through an Active Directory environment and understanding how, AV and EDR can catch you if you're doing a pen test. All right, with that, I think we're ready to get out of here. Let's see if there's anybody streaming if we want to do a raid. All right, I don't have anybody on, so I think we're just going to say have a great weekend, everybody. Be good to yourselves, be good to each other, and I will see you on Tuesday for some red team work. Take care, everybody.